So we're talking about quadrilaterals this week, and specifically today we are going to start with a certain type of quadrilateral called parallelogram. It's a hard one to spell. Parallelogram. It has two L's at the beginning and then one L. It's weird. All right, before I get into too much about parallelograms, there is one thing that I want to say about all quadrilaterals. For any quadrilateral, hold up, what's a quadrilateral? How many sides? Four. Okay, we think of squares and rectangles, but there's all kinds of quadrilaterals, okay? For any quadrilateral, the angles add up to 360 degrees. Okay? That's for any quadrilateral. So in a square, all four angles add to 360. In a rectangle, all four angles add to 360. In a parallelogram, which we're going to talk about today, all four angles add to 360. So that's just a side note. 360 is just a pretty easy number to remember. Do y'all remember what the angles in a triangle add up to? What's our magic number? 180. So right now you got to remember two numbers. Angles in a triangle add to 180. Angles in a quadrilateral add to 360. Okay, two numbers that you got to remember. Here, let's look at an example of how we use this information. It's pretty easy. Let's say we have this shape right here. It's got four sides, right? So it's a quadrilateral. Let's say that this angle is 78 degrees. This angle is 102 degrees. And this one is 100 degrees. And we want to know the fourth side, or the fourth angle, excuse me. So for any quadrilateral, if you know all four angles add to 360, and we know three of them, can we find the fourth one? Should be pretty easy. How are we going to do that? Take these three, add them together, subtract it from 360. Easy concept, okay? Just like what we did with the triangles. So 102 plus 78 plus 100. How much? 280? Yep. And then take that and subtract it from 360. That leaves us with the last one is, what, 80 degrees? Okay, so that just applies to any quadrilateral. Okay, the rest of this lesson is about parallelograms. That was just an easy thing I wanted to slip in there before I forgot about it. So let's talk about the definition of a parallelogram. What is a parallelogram? I believe you've probably heard of this before. You may not remember what it is, but you've probably heard of it. We know what the word parallel means, right? Two lines that are parallel, what? They're beside each other, but they never intersect, right? So for example, this line and this line are parallel, okay? All the lines on your paper are actually parallel, but these lines are parallel. They never are going to intersect. So a parallelogram, what this is this is a quadrilateral with two pairs of parallel sides. that should be an easy one for us to remember. A parallelogram is just a type of quadrilateral, meaning it has how many sides? 4. 2 pairs of parallel sides. So you're going to have a parallel set of parallel sides here. These are parallel. We already drew them. Do y'all remember the symbol that we use to show that lines are parallel? We just put little arrows on them. That means they're parallel. Okay? So I'm going to take these parallel lines and I'm going to turn it into a parallelogram by drawing another set of parallel lines here. These lines right here are also parallel, right? Are they ever going to intersect if they keep going? No. So I've already shown that these are parallel. To show that these are, I'm going to put their own arrows, and I'm going to put 2 of them. That's a parallelogram. What does it kind of remind you of? A lot of people say that this reminds them of a rectangle that's just been kind of pushed to the side a little bit. That's basically what it is, okay? They can be drawn lots of ways, but this is the one that we see the most often, is the one that looks like a rectangle that's just been pushed over a bit, okay? These lines are parallel. These lines are parallel, so it's a parallelogram. That's it. I'm going to draw another one for you. How about not great. Okay, there's another parallelogram. These lines here are parallel. And then these lines are also parallel. So there's your 2 examples of parallelograms. Okay, pretty easy. I am going to give this parallelogram some letters, so I'm just going to use E, F, G, and H. Right, like we always name the corners, the angles. You use these angles to name the parallelogram. Okay, so this is very easy. I don't want to overcomplicate this. If I told you to name this parallelogram, all you do is you pick a letter to start with. Say I wanted to start with E, and then you just go all the way around the shape using all of the letters. So I could say this is parallelogram EFGH. Or I could start at a different letter. But what you cannot do is you can't start at E and then jump down here to G and then go up to F and then jump. You have to go in order, okay? So say you wanted to start with F. I could say that it is parallelogram FGHE. You can even go backwards. Say you wanted to start at H. You could start at H and go this way, or you could start at H and go backwards. We could say it's HGFE. Okay, so those are just a couple of different ways to name a parallelogram. The main thing is you pick a letter, you go around it, you don't skip from point to point. You have to go in order, okay? Either direction, but you have to go in order. I'm going to stop this so there are 3 main properties of parallelograms, okay, that we're going to talk about. Property. I can't spell. Okay, the properties of parallelograms. There's actually a bunch of properties of parallelograms, but we're going to talk about 3 of them. I'm just going to keep using this parallelogram up here, EFGH, because it's a pretty good one. I did a pretty good job on that one. Okay, 3 main properties. Here we go. The first one. The opposite sides are equal in length. I'm just going to put are equal. That's a pretty easy one to remember, because if you look at this parallelogram up here, if I look at this, does this side and this side look to be the same length? Yeah. Basically, I took this one and I moved it down and over just a little bit, but they are the same length. Remember, when we talk about sides, we use two letters. So this would be side EF, and this would be side HG. They are the same length. They are equal. So over here I'm going to put EF is equal to HG. What do you think I mean by opposite? I guess I should clarify that. That just means across from each other, okay? Opposite each other. So these two sides are equal. What do you think it means about these two sides? They're also equal. So this side, what letters would I use to name it? EH is also equal to this one over here, FG. Okay, so that's property number one. That's a pretty easy one. Are we ready for property number two? In a parallelogram, the opposite angles are also equal. Now, what do you think I mean by opposite angles? We're talking about the angles that are across from each other. So, for example, up here in this parallelogram, which angle do you think is opposite from E? Help me out, guys. Opposite from E? G. These are opposite angles, and if you look at them, they look to be about equal. Is this an obtuse angle here? Is this an obtuse angle here? That doesn't necessarily mean that they are equal, but they are, because they are in a parallelogram. They're opposite from each other. So angle E is equal to angle G. What other angles are equal? Help me out. F and H, because they are opposite each other, they are equal. So angle F is equal to angle H. So again, the first two properties, pretty easy so far. Pretty easy stuff. I'm gonna stop it. Okay, last property that we're going to talk about. There are more, but this is the only other one we're going to discuss. And this is the only one that's a little confusing because the words are fancy, okay? The consecutive angles before I go too far, does anybody know what consecutive means? If I said that Barack Obama was the president for 2 consecutive terms. No? Never heard that? If I said that I was... trying to think of how else you might have heard it. I can't think of any examples. Consecutive just means in a row. So like Obama was the president, he won 2 terms in a row. He was president for 4 years and then again for 4 years. Consecutive just means in a row, okay? Like back to back to back. There's one. The softball team at Sheridan was the champion for 4 consecutive years. They were just back to back to back to back champions. They won 4 years in a row. That's all that means, okay? So here I'm talking about angles right next to each other in a row, okay? So consecutive angles are supplementary. Supplementary. I spelled it wrong. There's an N there. supplementary, supplementary. This is a geometry word that we have not talked about this year, and I have done a bad job for not talking about it. This word right here means they add to 180 degrees. And again, that's our magic number. A lot of things, I told you guys this, a lot of things add to 180. So in a parallelogram, angles in a row are supplementary, which means they add to 180. So let me come back up here to this diagram so you can see it. So if I take any two angles in a row, for example, E and F, because they're right next to each other, E and F add to 180 degrees. This angle, whatever it is, and this angle, whatever it is, they add to 180 degrees. So E plus F is 180 degrees. Any two angles in a row. So E is beside F, but E is also beside which other angle? Help me out. What other angle is beside E? H. So E plus H is also 180 degrees. How about F plus G? Are they in a row? Are they right beside each other? They are considered consecutive. That just means in a row. So F plus G is 180 degrees. And then what's the only combination we haven't done? We did E and F, F and G, E and H, G and H. So all of these combinations here, angles in a row, add to 180 degrees. All right, I'm not going to draw a ton of examples. I am going to draw several though. All right, so here we got a parallelogram. I'm going to give it letters P, Q, R, and S. And let's say this side over here is 10 inches. And this angle is 110 degrees. And we're going to find some of the missing stuff, okay? So let's start with, I want to find angle S. I want to find, what does angle S equal? Make this easy on yourself, okay? First of all, if I'm looking for an angle, I'm going to use another angle. I'm going to use this one right here that they gave me, 110. Do these angles look equal? P and S? No, right? This is an obtuse angle. This one is a acute angle. They don't look equal, so don't put 110 here. These are two angles right in a row, right? This is the last thing we just talked about on the other page. These are called consecutive angles. They're right next to each other. Consecutive angles add to a certain amount. What is that amount? 180. So if this one plus this one is 180, how do I find the missing one? Subtract it, right? 180 minus this one, and I get the other one. So what is 180 minus 110? 70? So angle S must be 70 degrees. Check yourself real quick. What is 70? If this is 70, what's 70 plus 110? 180. And two angles in a row are supposed to add to 180. Let's say I wanted to find angle R. Well, this one should be really easy because opposite angles are equal, right? P and R are right opposite from each other. They're equal. So if this one's 110, so is angle R. What if I wanted to find angle Q? Then it's 70, because if angle S is 70, the one opposite from it is. So now that if I just have one angle in a parallelogram, you can actually find all of them. Okay, let me ask one more question over here. How about, I want to know the length of SR. Now this is a side. SR would be talking about this side right here. SR is going to be equal to the one opposite it up here, 10. So if this one's 10 inches, this guy down here is 10 inches. I don't think I need to do another one of those, right? That's pretty easy. You just need to be looking at opposite sides and opposite angles, okay? All right, last examples that I want to do, and this is going to make you think just a little bit, okay? For each one of these, I want to know, is it a parallelogram? And if so, why? Okay, so we're going to do several of these examples, and then that's going to be our quitting point. Number one. I know you got to draw diagrams. I don't like that part of taking notes, but in geometry you got to draw them, or you don't have anything to look at. All right, so this one should be pretty easy. What do these arrows mean? That they're parallel. And remember, if this one has 2 arrows and this one has 2 arrows, the ones with 2 arrows are parallel, and the ones with 1 arrows are parallel. So I'm giving you a diagram, and I'm saying these sides are parallel and these sides are parallel. So is it a parallelogram? Yeah. Why? That's literally the definition of a parallelogram, right? The definition of a parallelogram is 2 pairs of parallel sides. 1 pair, 2 pair. I'm just going to say yes, both sides are parallel, and I'm going to abbreviate. Okay, you ready for the second one? Trying to draw them a little bit different, but I'm not very good at that. Okay. All right, so draw that quadrilateral and then make sure you put the tick marks on it. What do the tick marks indicate? Do y'all remember? These two have 2 tick marks. These two have 1 tick marks. What does that mean? They're equal. So they may not look equal, but if I tell you this side and this side, they both have 1 tick mark, they're equal to each other. And if these sides both have 2 tick marks, they're equal to each other. So I'm telling you that these opposite sides are equal and these opposite sides are equal. So do you think that's a parallelogram? I don't know if y'all said yes or no, but that is the first property of a parallelogram. If the opposite sides are equal, then it's a parallelogram. So here, these opposite sides are equal. So yes, this is a parallelogram. And my reason? Opposite sides are equal. Okay, I want to do a few more. All right, here's a quadrilateral. On this one, I'm going to give you the angles. I'm going to say this one's 80 degrees, this one's 80 degrees, 100, and 100. So, do you think this is a parallelogram? Here's what you got to ask yourself is, do I have one of the properties? What property do I have here? I don't know anything about the sides on this one, but I know the angles. These right here are opposite angles, right? They're both 100 degrees. These are opposite angles, right? They're both 80 degrees. Y'all, that would be this property right here. If the opposite angles are equal, then it's a parallelogram. Are the opposite angles equal here? Yes. So yes, this is a parallelogram, and my reason, opposite angles are equal. Anytime you have opposite angles that are equal, it automatically is a parallelogram. Okay, fourth one. All right, what do y'all think? Is this a parallelogram? You don't want to go based off of looks, but you should ask yourself, does it even look like one? Are these lines here parallel? No, they're not. Eventually, if they were to keep going, they'd intersect up here somewhere, right? So these are not parallel, and they didn't tell us. They told us these were parallel, but they didn't tell us those were. So that means, no, this is not a parallelogram. This one only has one pair of parallel sides. It's got to have two pairs. All right, I'm going to do two more here. Alright, so on this one, these two sides are both 6. And I even put 2 tick marks on them to show you that they're equal. These two sides are both 4. And I even put 1 tick mark on them. Is this a parallelogram?
No.
Why not?
No.
Well, the sides definitely aren't parallel, but I have sides that are equal, but these sides are not opposite each other, right? These are next to each other. These two are supposed to be equal, and then those two are supposed to be equal. So I'm going to say opposite sides are not equal. If your opposite sides are not equal, it is not a parallelogram. All right, last one. I'm going to go 3, 3, 5, and 5. Okay, to finish this one up, what do y'all think? Is this a parallelogram? Yes, it is. Why? What do we know about these sides? They're equal. What do we know about these sides? These are opposite sides. Opposite sides. That's that first property we talked about. If opposite sides are equal, then it's a parallelogram.